Hey guys, so using the turning point format of a quadratic function, we're going to practice sketching the parabolas out. And when we're sketching, we just want to keep in mind that some key points of a parabola, as we see them here, the y-intercept, the turning point, or this vertex up here, I like to call it a turning point, and of course the x-intercepts as well, or as we might call them, the roots. So when we're thinking about sketching out a quadratic function, we kind of want to nail down those key points. This question here, it's only asking us to label the turning point and the y-intercept. Okay, so let's start with a. Y is equal to 3x squared. Well, since we need to find the y-intercept, the first thing I'm going to do is I'm just going to find the value of the y-intercept. And of course that occurs when x is equal to 0. So y is equal to 3 times 0. Well, that's just going to be 0. We'll see that the turning point occurs at the origin, 0, 0. So this quadratic function, according to A, B, and C, how we've seen A, B, and C for, sorry, let me just write down our turning point format. Y is equal to ax plus b plus c, and that's squared. So A, B, and C, we've seen how these three constants affect our parabola. Well, A, that's the dilation factor. So I can see that y is equal to 3x squared. That's just going to be a basic parabola, but it's going to be dilated by a factor of 3. Its gradient is going to be increasing 3 times as fast. So that is just going to look something like this, a steep parabola basically. And if I wanted to just chuck some more information on that, because we're sketching this, so that means there's no numbers on our grid right now. So who's to say that's not just y is equal to x squared or y is equal to a half x squared, right? Well, you need to kind of put a little bit more information than that. What I like to do, I like to just ponder what's this quadratic. Well, where's this quadratic going to be when x is 1, for example, or -1, or whatever you'd like to pick. I'll just pick 1. Well, we'll see that y will be 3. So we have another coordinate point 1, 3. We can just plot that in. Maybe that's here, for example. 1, 3. We'll just plot that coordinate point in as well, just to give a little bit more information. So it's not just a, sketch with no meaning. Anyways, B. Let me get my blue pen out. Y is equal to -x squared plus 4. So again, I'm just going to find this y-intercept first. That's going to be when x is 0. Well, that's just going to be 4. So the turning point... Oh, sorry, not the turning point. Did I say turning point here as well? That was meant to... Well, it was the turning point for A, but I meant to say the y-intercept. Sorry. And here for the blue, the y-intercept is going to be 0, 4. So maybe that's up here somewhere. Alright, so this quadratic equation, according to the turning point format, we've reflected it about the x-axis based on that negative, and we've translated it 4 spaces up. So it's going to have a dilation factor of -1, which means it's going to be reflected, but the rate at which the gradient is increasing is going to be 1/3 of the rate at which this red parabola is increasing. So just to kind of estimate, that might look something like this. I don't know. Maybe we'll just sketch it out rough first. Maybe something like that. So it's dilated, not as steeply. It's not as steep an increase in the gradient. Right, and now just to, again, get a bit more information on this, I might just again ponder, well, what's y going to be when x is 1? -1 squared, that's just going to be negative. Also, 1 squared is 1, negated is -1, plus 4, that's just going to give me 3. So I actually see that another coordinate point of this blue parabola is 1 and 3. It's the same as this red parabola, so actually we should be intersecting our parabola here at 1, 3. I didn't do a very good job of that. Let me try again. And that'll do. So we should be intersecting there actually, 1 and 3. But anyways, finally we've got this green parabola. Again, we need to find this. Oh shoot, we were supposed to put the turning points in as well. I'm all over the place. Sorry. So for this red one, our turning point, that's this point of not inflection. That's like, well, it's kind of like the corner of this parabola basically, where we turn from one direction to the other. So here if we imagine we're going left to right, we're decreasing, and now we're increasing our gradient. So the origin here was 0, 0, and the origin here, which also happens to be the same as the y-intercept, was 0, 4 up here. Okay, and both of these intersected at 1, 3. Alrighty, green. So for green, I see that there's been no dilation. A is 1. There's been no vertical translation. C is 0. But B is -2. Now remember, if B is negative, that means a shift in the positive x direction. So if I have x take 2, that means I'm shifting 2 spaces in the positive x direction. So here was x is 1. We'll say x is 2, and we've just got a dilation factor of 1. So the dilation would look basically like just the reflected in the x-axis of this blue parabola. So estimating that, it would look something like this. Oh, something like this. Just a rough estimate, and we'll just check to see again, just to add a little bit more information. But by the way, the turning point here is just going to be 2, 0. But just a little bit more information, we will see what is y when x is 1. 1 take 2 is -1 squared is equal to +1. So we have the coordinate point 1, 1. And for the y-intercept, that's going to be when x is 0. So that's just going to be -2 squared. That's going to be 4. So actually, that was bang on. So we're intersecting, this green parabola is intersecting the blue parabola right at its turning point. Alright, nailed it. Cool. Thank you for watching, guys. Hope that helps.